Good morning, everyone. Thank you for joining today. For those of you, this is the first time in this tool, please take a moment to familiarize yourself. If you want to ask us questions, use the Q&A. We'll be monitoring that. We will not be monitoring the chat live because it's just too much content. And if you want to, please in the chat box say where you're from. So I'm usually in Houston, Texas. I'm currently in West Springfield, Massachusetts. And so some things to be aware of. We will take questions at the conclusion. And so if you want to hold off till the end, that's fine. You can also answer or ask a question during, and I'll do my best to see them come in and get the question asked along if it goes along with the flow. Anything that we don't actually get to today, we will follow up separately with an email or have it available online to make sure that all the questions are answered. So the track is 58 minutes, and I will do my best to end on time. I'm sure that the organization, Lucian, will cut me off if we go too long. But we want to thank the sponsor of this session, Influx Data. Our topic today is From Machine Data to Business Insights, Building the Foundations of Industrial Analytics. And just so you know, data is one of my favorite topics in manufacturing, and you can solve any problem with data. But first, you have to get the data off your shop floor into a usable format. And our experts will be discussing the challenges and opportunities, as well as some best practices for implementing solutions. And I'm super excited because the three of these products and these people together is really a smart solution, and they're an engaging group of people, so I hope you enjoy. So thank you, and we want to first introduce the speakers, so I'd like for them to introduce themselves. Jay, can we start with you?
Yeah, absolutely. Thank you so much for the intro, Jane. That was great that you sort of took in all our products there. I guess I should do the same as you. I'm Jay Clifford. I'm currently in the UK, but now in California for work at the moment. I worked as an industrial IoT solutions engineer, so plenty of manufacturing floors, deploying Kepware, edge-based devices, InfluxDB, collecting data from the shop floor, and mostly visualizing it with Grafana. So very much in the same boat as a lot of people here, I would have thought. And now working at Influx Data in developer relations, so helping the next level of sales engineers on their journeys through these times in industrial IoT.
Great, thank you, Jay. Mark?
Hey, hello, everyone. I'm Mark Pose. I'm based in Barcelona. I'm currently as well in Barcelona. And I'm working at Balena as developer advocate and helping a lot of companies on industrial IoT to enable them to update the software remotely from their gateways in the factory floor, etc. I'm as well community manager of the Internet of Things Barcelona communities, IoT Stars, and I'm running several podcasts as well about industrial IoT, like the IoT Coffee Talk.
Okay, thank you. Very nice. And Kyle?
Yeah, hi, good morning, everyone. And thank you, Jane. Thank you to everyone else. My name is Kyle Carew. I work for Kepware as a sales enablement, or I head up our sales enablement team, similar to Jay, sort of helping the next generation of application engineers, sales folk, kind of get their hands around manufacturing data in Kepware. Currently based out of Portland, Maine, but now, like everyone else, I'm actually in Boston for a PTC event. But happy to be here and excited to talk about data with you all.
Oh, great. Okay, great. So thank you. So let's get started then, because I know that the audience would like to learn more about what the topic is. So first question, and we'll start with Kyle, but please everyone chip in. How has the importance of machine data evolved in recent years, and how is it shaping the future of industrial analytics?
Yeah, thank you. Yeah, it's a great question. So it's been really interesting, right? So if we bring it back to, we'll call it the late 80s, early 90s, that sort of time frame, the next generation of PLCs was coming along, and forgive me, former Rockwell guy, so I might have some of those Rockwell references, but like the PLCs 5s are going to the SLIC 500s now, so that the PLCs are becoming a little bit more advanced, which is great. And now we've got these sort of tag-based PLCs and then tag-based data, which allowed us to do a lot of more sophisticated machine-specific control, but that was all based around local control. There was still a need to gather data for OEE and those types of applications, but it was still very much, sneakernet. It was a lot of very manual process. As time moved on and the technology got more advanced, we were able to figure out ways to gather that data to make these bigger, more advanced analytics type of decisions. So what's been interesting is that the importance of data, it's always been there in the machine, but really it's evolved from local control to more of this much grander sort of holistic approach to how can we gather this data from the machine. So going from control to more, how do we monitor this? How can we get actual OEE type of data from the machine? So it's been very interesting to see that, where again, like the data really hasn't changed that much, but it's how we're gathering that data and how it's being applied.
Yeah, just on to your point there, Carl, I think it's you sort of the granularity as well. We're seeing sort of much high resolution in terms of samples. For us, some people are looking mostly in the milliseconds now, if not sometimes nanoseconds, depending on what types of machines that they're using. So it's a sophistication. I think people have got an impressive amount of data that they want to utilize in certain ways. And I just think it's an interesting new milestone to cross now, where before we were dealing in seconds, we've got a lot more to deal with now.
Yeah, and I think what's been interesting too, I think when folks started to realize how important that data is, and a bunch of customers back in my Rockwell days where you'd go and they say, hey, we're interested in getting that data. And I would say, well, great, well, how much do you want? Right. And they'd say, oh, all of it. And at that point it was, okay, are you sure? Because I don't think you realize how much that is. They get all the data and you go, oh yeah, we can't, that's too much. Let's scale it up.
Yeah.
But what's really interesting now is that technology of those advanced analytics has caught up. So now we can actually ingest all that data and start to do really interesting things. So it's a sort of leapfrog effect that we've been experiencing.
Exactly. So cool.
I think it's a great point. I started my career many years ago as a control systems engineer, control engineer. And the amount of tools and the availability of data is just infinitely more than it was when I started. And to try to say, when the data scientist said, oh, I want to do some analytics, and I want the whole chunk. It's like, no, it's a mess. You don't want that. Okay, let's move on. So what are the most significant challenges organizations face when collecting, storing, and analyzing machine data? And how can these challenges be overcome? So we'll start with Jay, but please, I want to hear from everyone.
Yeah, so I guess before we sort of drive into those three areas, I think the best thing to do is sort of break down the umbrella problem of what everyone's trying to achieve when they're collecting machine data. And the first thing they'll tell you is monitor my machines because I want a return of investment. And, there's plenty of ways to see this return of investment. But the main way people see it is either through operational efficiency. So how efficient is my current production? And then overall equipment effectiveness. So, are these machines running optimally? This sort of goes into sort of predictive maintenance, making sure that I don't have any machine downtime, etc. So it's really, how do we go from the raw ones and zeros and all these tags that we have, and then deliver business insight for people that want it, and then everything in between. So I think if we have that in three stages, sort of data collection, data storage, and then the analytics, that brings it into this BI world. Data collection is one of the hardest, and I think Carl will tell you this himself. I think this is exactly the reason why Kepware exists. We had a spaghetti fest of so many different providers, PLC makers, who all had their own protocols, and they essentially just didn't want to play ball in the same space. Yes, we have OPC UA and MQTT and Modbus now that's standardizing the industry, but again, a lot of providers still provide their own connection suite. Some of them can't even connect through standard means. So you need something there to be able to collect the data from a variety of means and standardize that data. Once you're past that hurdle, which is a huge hurdle not to be taken lightly, you've got to store that data. And that's when we talk about fidelity and the amount of data you want to store. We was on site at one point at one manufacturer, and they said, can you pull data from that machine? And we had over 10,000 tags that we were pulling from that one machine. And most of it was fluff. We didn't actually need all that data, but how do you filter out without seeing or storing most of that data first? And some of that you can do with Kepware, some of that you can do when you store it within, say, like a time series engine that can cope with the amount of data. And then I guess lastly, to bring it all out, once we have it stored, is how do we actually turn it into business insight? How do we build those models for analytics? And this is normally where OT and IT collide. If you talk to any data scientist or data engineer, they'll be like, give me the data exactly the same, shaped exactly the same way, so I can deal with it, I can work with it, I can build a usable model. If you ask the OT engineer, they'll be like, what does that look like? Do you want it in an XML file, a JSON blob? Like what's the structure? And I don't think I can do that the same way for every machine. So I think there's a lot of miles. They all sound like scary miles. And this is where, there's a huge space within our products, not just ours, but in the space in general, where that we're trying to fill that gap to sort of allow people to sort of build off their solutions to deliver those BI results.
Yeah, absolutely. I think, the digital transformation, it's a real challenge for organizations, no? And we need leaders that, take this very serious, no? And are ambitious to lead these insights, because probably people, right, will be one of the challenge, not to organize people to make this happen.
Yes, I mean, the digital transformation needs to be a full strategy, not one project at a time, not one thing at a time, but really going towards monetizing data. And Kyle, I'm sorry, I think I interrupted you.
Oh, no worries. I was going to agree with Jay there. Like, and again, my answer might be a little bit biased coming from Kepware, but I think for real though, like, I think we're at a point now with technology, especially in our space, where if you can dream about doing something, we probably have the technology to do it, no matter what platform you're using. But regardless of what technology you're using to do analytics, to do machine learning, to do all that stuff, no matter what you're doing, you need that machine data. And what's been super fascinating, and I think, Jay, you touched on it a little bit here too, is when you're looking at these factories, you have that capital equipment coming in that's, has an ROI of 20, 25 years. So you kind of have this mix of modern and legacy machines, and maybe even different types of PLCs on those machines. Again, both modern, legacy, talking different protocols. That is the biggest challenge. And from what we've seen at Kepware, is customers who don't solve that connectivity challenge early in the process, that project fails every time. It's one of those things that you absolutely have to get that foundation set, and then everything else moves slowly for that project and for future projects.
Agreed. And that we did get a question from the audience, and I think it goes perfectly with our next question. So the question is from the audience: how do you best determine the value of machine data and whether or not it's going to be worth the trouble? And I think this is a great question. And it goes along with the next one where Mark will start. And how do edge computing and IoT solutions contribute to more effective and efficient industrial analytics? And can you each give us some use cases that demonstrate their impact? And I think that will answer the question. So Mark, can we start with you?
Yeah, so I will focus on the edge, but before that, I would like to complement maybe the introductions from Kyle and Jay, talking about maybe the industrial 4.0 steps that I see, and probably have been already commented. But first of all, of course, everything it's connected or has a PLC or something where data usually go into silos, right? That we need to recover from. Then the next step of the industry 4.0, it's probably collect the data and make this data available for anyone. Next step might be to analyze and start discovering these connections between systems that are not really apparent in the real life. And finally, this system needs to help, or this digital transformation needs to help to allow the company and decision makers or people in the IT or OT to take decisions. We can discuss later about if these decisions must be in real time or not, or must be led on by automatically or not. But this is at least the step that I see on the industry 4.0. And I think on these steps, the edge is really key. Okay. But answering your question about so what is solutions that contribute to be more effective or efficient. For the thing I would like as well to give a lot of power, just to make sure that the data is properly captured, it's the software running on the hardware. And to have the ability as well to update the software running there. Because if we have this ability, and this is something that every day I see more and more companies that don't have the possibility to update the software or the operating system running in the edge. This is something that can cause a lot of problems. Okay, so you cannot fix bugs easily. You cannot actually deploy new versions of the software that you might need. And basically, trying to go to answer your questions. I think, it's really hard to determine why. So what's the value or the return of investment of getting the data? You need to have like a strategy, as we mentioned before when you decide to go to get these 10,000 tags that Jay mentioned before. And you need to have like a whole definition of your manufacturing stack to have all the tools available for all your team, the IT and OT, before getting these decisions. And actually, I will say again that the edge plays here a really important role.
Yeah. Oh, go ahead, Jay. After you.
So I'd have to just agree with you there, Mark. I think for us in my previous job, we specialize in just throwing edge gateways into the mix all the time. And it was just the reason why edge plays such a role for us was because the closer you are to the data, the faster you can react, and you have a much more closed loop cycle. And that sort of goes on with InfluxDB now as well, where we have a lot of people storing all their high fidelity data, they're monitoring it at the edge, and then causing, either alerts to happen or giving that to the site engineers at the time, or then they're offloading the rest of that data, or at least an aggregated or downsampled version, to some form of like remote instance, whether it be the cloud or another server, where they can do later analytics or post analytics on that data. So for me, the edge is extremely important for being that very closed loop cycle. It's you need that sort of millisecond reaction time to certain events that might be occurring.
Yeah, and what's interesting about the edge too, and I think for the question that was chatted in, around the value of machine data, I guess I'll start with that and I'll loop in the edge here. But I think you need to start with, what problem are we trying to solve, or what thing are we trying to improve? So is that, hey, we've been having quality issues, how do we address that? Is it, hey, I need to improve efficiency? Hey, we've had a lot of unplanned downtime, how do we reduce that? Start with that problem, and then you can start architecting out how that looks. Now, where the edge comes into play is actually, again, that's going to be application specific. So I think if we're looking at factories, you could almost make the argument that, like, well, we have always been doing edge computing because we have PLCs on machines, they're doing all those decisions. That's a whole other conversation. But if we look at something like oil and gas, like, there's more, in my opinion, there's more of a need for those types of edge solutions where, hey, I've got on my pump sites or my well site somewhere, I'm doing, maybe I have an instance of Influx down there that's doing all that analytics at the edge that needs to have that real-time split-second decisions down at the well pump. But hey, maybe once an hour, I'm sending something up to the cloud for longer storage. So edge computing is great. I think there's a huge place for it, but I don't necessarily think it's a blanket solution. I think it's very application specific.
Yes, thank you for that. And just my own response to the question that came from the audience was that the way you'll know is to try it. And I know that sounds a bit sarcastic maybe, but that's what we've done in the past. Is we'll find a use case, so a proof of concept, and we'll prove that what data is available and how to add value with that data. Okay, so let's move on to the next question. So can you, with what you've seen, and this is first directed at Jay and Kyle, but please, Mark, jump in. Can you provide some examples of how the advanced analytics and machine learning algorithms have been integrated into the industrial process to improve efficiency and decision making? I know that in manufacturing, many companies are behind and need some hints on how to actually start doing that. So I'd be curious to hear what you're seeing as far as integration into the industrials.
How would you like to take this one first, and then
Sure. Yeah. I was gonna say, so I can give a sort of high level, and again, like with Kepler in the focus, like we're really just focused on taking data from one place, pumping it out to another. So what I can, I guess, offer here, a couple things. One, I think it's important to start small, but have the notion of scalability in mind when you start small. So that's one of the things to definitely to think about. But cool little anecdote story that I have heard from Kepler before that's been very interesting. And again, this kind of goes to maybe not advanced analytics per se, but the idea of, hey, there's a lot of different data sets and how they can intertwine. But we worked with an automotive manufacturer who was having once a year these weird quality issues right around April. And what ended up happening for years, it was, again, it's always within a week or two period of just weird paint issues, I think it was, and no one could figure out why. Eventually it kept going up the ladder, people with more oversight into the data. And there was this one gentleman who basically said, give me all the data sets of everything in the factory, everything from the process, from the operators, the maintenance schedule, the building automation HVAC data. And when he looked at it, he actually noticed that the HVAC system, April's about springtime. So every time during those 2 weeks period is when the HVAC would go from heat to AC. And that was the time where they're getting these quality issues. They went, oh, look at that. I don't know exactly what they did, but they ended up solving that problem. But again, you look at it, you can make a case that it's advanced analytics because you're looking at a larger data set to try to solve the problem. And again, the comment I made earlier, where in the past, there was these sort of silos of automation and silos of data sets, which are great, but we didn't necessarily have the means to crunch all those larger data sets, and now we do. So fun little anecdote, again, not necessarily an advanced analytics expert like Jay here, but cool little anecdote.
Too kind. No, I think, Carl, to add to that, I think that's a perfect use case of where we've actually applied, a collection of different data points together, and with that global visibility over our data has given us the insight that we've required, where if we looked at narrow vision directly at that machine, we would never have guessed what had taken place. I think we sort of touched on them a little bit earlier, but the two that we see a lot of the time when InfluxDB or any sort of storage engine is utilized is predictive maintenance. First of all, we used to do a lot of use cases that started really basic, where they would basically monitor vibration, and they would basically say if you had, I don't know, 4 or 5 CNC machines all running the same jobs, they should all be in the same realm of vibration levels, along with other characteristics within their PLC programming. And basically, if one starts to malfunction, we can basically evaluate based on a threshold detector, sort of like if we're getting really fancy, sort of like sort of medium average deviation. So it's deviating from the pact. From one another, you can go, hang on, there's something odd going on with this machine. Do I need to proactively apply maintenance, or at least send an engineer to look out before something goes down? The one that's been a bit more interesting and I never saw coming, and has been a bit of a learning curve for me, is we've actually had a few of the larger manufacturing firms now actually using highly granular machine data that they're collecting to then create digital twins to then train their PLC engineers on how to basically write more efficient code for their machines. They basically use it as like sample data, and they can then use that data to either sample issues, or they can sample basically standard operations or new operations and work out, okay, if this is a problem, how can we program against this, or how can we change how this PLC transitions in the future? So yeah, I think that it's like there's not all these, if I say it, completely sexy analytics engines out there, but I feel like it's starting with the basics of analytics and then building on from there. And then you could start applying ML models and algorithms to what you're trying to do. But I think I'll hit it on the nail on the head. It's visibility and not being so narrow visioned on just certain machines.
if I can add something here, I think it's super important that companies have a clear data modeling strategy as well. Because when you have data model defined on the top of your stack, you're able to decide what to use on the top of that, right? So it's easier to run specific algorithms for advanced analytics or digital twins or predictive maintenance and so on. So I would also mention that it's really important that you have like a clear data modeling for your assets and your devices.
I agree with that. I worked for a German company for most of my career, and everything was structured and standardized. And it wasn't until I actually left that environment until I really, truly appreciated how that was. Yeah, very interesting. But I think this is a nice segue into the next question, which is more about infrastructure. And for all of you, so what are the key components of a robust and scalable industrial analytics infrastructure? And how does Elena, Influx Data, and Kepware support these requirements? And this actually goes along with one of our audience questions where they were asking, if you do a proof of concept, and like say on the paint quality, for example, how can you later build the architecture to do the whole vision? And so maybe if that's a way for the three of you to tie that in together. So maybe Mark, start with you.
Oh, wow. Yeah, this is a really interesting question, actually. Yeah, maybe I will not talk about technology here, just to start answering the question. I would talk about the people who had to deal with this task before, right? And some of them are, the developers that needs to build that. So if you have a clear strategy on your digitalization and you can explain that to your developer team, if it's ISV or if it's your internal team, I don't care. But try to give them like a clear vision of what you want to do and what are the steps or the stages that you want to build it. Okay. And as well, have in mind something that I'm tired to see Windows Vistas and Windows 98 to get data from PLCs and all of these types of devices. And probably developers too, millennials, when they will arrive to work along with us, they will hate to see that because they have never seen that before. So I would say if you work on brownfield scenarios, not on greenfield where there is new machinery, just try to as well bring new technology. So developers and people is motivated to learn these new technologies. I usually say these 21st century toolkits like Linux, containers, and all of these type of technologies needs to be there. And this helps to scale. And this needs as well to have the team behind it motivated to learn new technologies and new skills to be part of the solution and all the different stages of the technology. I don't know, Jay, if we can give as well an example of what we built together, or I don't know.
Yeah, and I fully agree with you there, Mark. Like I feel the mindset now is hopefully to build a open solution, allow the builders to bring the Lego blocks and build them together how they see fit and have much more control over their overall solution on site. And I feel but those components that you bring in, they have to have a mindset for scale as well. Like from the ground up, InfluxDB was built for scale. You could come in with an open source single node. And then if you're like, okay, well, I need HA and I need to scale to 10,000 machines plus, you should be able to do that without needing to change anything that you've implemented before. And I know, and into that open solution, we all have to be ecosystem players within it. And that comes down to us as providers of that. And this is where I think sort of Balena, InfluxDB, and Kepware really come into play. We all know we facilitate a component of the solution, and Rome wasn't built in a day. So it's very much like, Kepware is designed to handle all of the data piping, connections. InfluxDB is there to act as this additional data historian, this part of storing high fidelity data, whereas Balena is there to basically deploy and maintain all of these edge devices, all of these other IoT sensors out there without you needing to worry about going around with a USB and plugging into everyone. And I think that's the testament to how we can work together. We've had so many webinars between each other now where we've just been able to plug and play into each other's solutions. And yeah, I think that's the future rather than looking for off the shelf components which try and do it all for triple the price.
No, for sure. And I agree with both of you too. And Mark, I love the comment you made about, it's sort of not always about the technology. And I mean, man, I couldn't agree more. I hope by now that most people are aware, like the IIoT convergence, it's not a buzzword anymore. It's a real thing that's happening all over. And it's important. And I think it's important to have, if you will, executive sponsorship at the top. It is a culture change in order to do these sort of things. And it starts from the top, from an executive level all the way down to the controls engineer on the floor. But if we do talk about technology, obviously I agree with both of your points. And the other thing I'd like to add is, we talked a lot about visibility of the machine data, but I think it's also just as important for visibility into those solutions that are deployed. So how do we maintain a container? How do we know that our instance of Kepware or Influx is up and running? And can we troubleshoot that very effectively? Can we troubleshoot that from a centralized management platform? All of that. So it's visibility not only to the data, but also into the software that's being deployed.
I agree. It's like if we can't monitor ourselves, why should we be told to monitor anyone else? So yeah, that's good. Good point.
No, and this is super relevant because when you launch new versions for your customers and they are not, so imagine that a new feature is on a new version and they are not allowed to deploy it on, or they don't want to stop, I don't know, the factory. Sometimes it's really tricky. So yeah, it's really important that the company has a governance of the stack, and it's not the stack who decides what the company will do next.
Yes, I agree with what everyone's saying. I think, Mark, what you started with on people first is absolutely key. That's how I've worked the last 30 years, is trying to do more of a bottoms up. And having scalable technology is super, super important. And I work as a venture partner with Momenta, and we evaluate industrial tech startups. And that's always one thing we look for: is this actually scalable? It's super cool, but how can we scale it? And so it's very interesting. So I think we can move into some best practices, because especially with a lot of the machinery, like you mentioned, the Windows 98 machines and moving data with USB port. So what are some best practices for implementing solutions with those legacy systems or limited technical experience?
Yeah, I can take that. I mean, that's Kepware's bread and butter, but I'll do my best not to make this a Kepware commercial. But I think the idea here is if you look at, any, I'll go to a SCADA system, right? Most SCADA system providers, whether that's Rockwell with FactoryTalk, inductive automations, Ignition, no matter what you're using, a part of that SCADA system is going to have some sort of data server or OPC server, which is great. It is a key component. However, when you look at that, they may not have they may not have the legacy drivers that you need to connect to that. Most likely they're going to have either the open Modbus protocols or just their own stuff, but they won't have competitors, because why would they do that? So really what you need to look for is a data server that is agnostic and can support modern and legacy protocols and drivers. So we're not just talking about, connecting that to the PLCs, but also, I guess, if you will, a northbound. So, hey, sure, everybody's talking about MQTT and SparkPlug-B and OPC UA, which is great, but hey, there's a lot, I mentioned earlier that 25-year ROI for these machines. Some of them are probably still talking OPC DA, which, if you are, please look into that. It's a big security thing, but there is still a need to support that. So you need to have, a solution that is agnostic and also just decoupled. So the other portion of that is, hey, if you want to replace your SCADA system, or if you want to go with a different industrial analytics solution that has a built-in data server by itself, you then have to redo that if you're going to replace it. So just by having, again, that agnostic centralized system, you can kind of just bypass that, and you have a good solid foundation for getting all the data and just building on top of it.
Yeah, and I think sort of to your point, Carl, we kind of when we were delivering sort of industrial solutions, when we sort of did the factory tour, we would look at the oldest machine first and go, is this feasible? And, you know, is this it's almost like that funnel effect of what's your importance? What's the importance of getting this machine first? What value you're going to get if we start taking data from this machine? And then versus what's the easiest connect to, you know, does it provide you value? Now we always agreed to start small and scale, so you can actually start seeing notable value. And yeah, I agree to all your points. It's very much having the mindset that you do have the northbound direction as well. There's plenty of other solutions that people want to start integrating to. And it's also having that, and we talked about people before, it's that buy-in. There's probably a lot of people on your shop floor that might have more expertise with that machine, or more expertise with the especially the engineers as well. So getting them on side and building the solution with them and scaling from there is also a win, as well as having overall buying from the company as well.
Yeah, I will kind of give a third solution, like a third way here from what Kyle and Jay suggest here. But I'm actually lately helping companies to start POCs on the industrial ecosystem, and I'm trying to push towards like a stack, a new kind of a stack. Like, I don't know, anyone here remember the LAMP stack, LAMP stack, no, in the late 90s, that help a lot of developers to get into the web development with Linux, Apache, MySQL, and PHP. I'm trying to push a stack called Ming, M-I-N-G, stack that stands for MQTT, InfluxDB, Node-RED, and Grafana, just as an initial stack to start doing POCs on whatever. And actually what I discovered is that there are real deployments of the Ming stack on industrial IoT, on industrial factories, yeah. At least around here, Barcelona, with the IIoT community, I have seen several of these deployments. And this is actually not super scalable, probably, but probably Node-RED can give this initial layer in the edge that allows anyone to get most of this legacy data from this legacy machinery on the factories and start digging of what's going on there and start storing the data in the edge on an Influx instance, and then maybe visualizing with Grafana. And then if you manage this edge yourself and you are able to update it, then you can decide, okay, I have everything that I see that this is usable. I can see a return of investment of this. Okay, let's go to the next step. What do I need that it's more professional or enterprise here? And let's update these machines, or let's add new machines on the ecosystem just to make it happen. But I would start small, I think. And I think it was a question from before, how to start a POC. And I didn't reply to that, but I think, yeah, something like this can help to start small.
Yeah, definitely. And I think one of the things too, Mark, you kind of brought up there too, is having that, or actually, I think we've all talked about it, but just having that ecosystem. So, you know, and my favorite thing to always use is like, if you're starting up a craft brewery or something, like you probably know how to make beer, but you don't know the finer points of industrial analytics or machine data. You know how to brew beer, and that's great. So you're going to look to someone, whether that's a system integrator or rather that's a vendor, but you need to partner with that person or that company to help move you along. And hopefully that vendor has that ecosystem in mind, where they're saying, hey, we can do a lot, but we can't do it all. So let's have these partnerships. Let's have folks like, the three of us work together to help out a customer. So I think that's a big, important point to bring on. The other part of it too, again, I know we keep saying start small, which is important, but the other part of that sentence is start small again, but with scalability in mind. So if you don't have that in mind, you're going to run into that pilot purgatory. You're going to have a one-off, and you're just going to create another automation, which is what we want to avoid in the first place.
Yeah, this is why you need to have under control the edge. Yeah, absolutely.
Definitely. But along with that, the companies need a way to measure the return on investment. and further analytics and KPIs and things like that. As much as we all hate KPIs, it's actually a very valuable way to understand your progress over time. So the question I have for you all is, what are some of the KPIs that you think companies should track, and how can they measure this return on investment with these proof of concepts? How do we, justify and scale in industrial analytics and things like that?
Who wants to go first?
It's for everyone, so it's a free for all at this point.
Go for it, Jay.
Yeah.
So I think we sort of touched on, I think we touched on a few earlier, which was sort of looking at operational efficiency and overall equipment effectiveness. But I think, as they're valid, but they're also buzzwords in the industry. And it's sort of how do you get down to a practical level of delivering some of these? But as we said before, starting small and then scaling your expectation. I feel a lot of the time industrial IoT solutions fail because they fall short of what the buy-in levels expectations were for that solution. And so some of the ones that we've discussed in terms of saving time is measuring sort of looking at machine downtime, measuring how long it took an engineer to get to that problem. Did we reduce the amount of time that it took the engineer to even find out what the problem was through the data that we've provided? I think that's to sort of Kyle's point there, which is with his previous story was, it was they managed to find a very minute detail through their data, which caused a greater impact to their overall production. And that should be considered as a KPI, a manageable change that can be scaled to operational efficiency or to overall equipment effectiveness later. And I guess sort of the second side of that is making sure that it's enabling your site managers and your engineers, make sure that they feel like the technology is of benefit and as of a tool to them, rather than it just being a window into the factory for yourself. I think as long as the site engineers are a master of that data, they feel that they can take that data and proactively make good change to the production of your facility, or the engineers feel that they can, drive better results. These are the important KPIs to start with, and then scale them to greater, more broad terms later on.
Yeah. This is very good. I would love to be controversial, but let me add something else first.
Yeah.
And it goes to my first intervention, talking about the Industry 4.0 strategy. What I think on return of investment point of view here is that some companies are in this stage that they are collecting all the data and making all the data together, on a data lake or whatever, or on a database. There is no return of investment of this. Some companies are in the next phase, right? That they are starting to do analytics or advanced analytics on the top of this data. I don't think there is still a huge return of investment of this. I think the huge return of investment is in the last stage, which is that you can take the right decisions in real time or not, and you can start making sense of everything. But if your company is on a previous stage of this Industry 4.0, the return of investment is really hard. And I love all the beef that Rick Bullotta is introducing on the social networks about he's completely against OEE, for example, KPI. So yeah, I would be very careful with KPIs before we get into this stage where you can take decisions because they are data-based and they are go towards a specific direction. Because remember that people just can change their behavior to cheat KPIs, right? Or they can even lower the standards of what they do to improve a metric. Okay, so I would recommend that metrics should help to model how your business works, or just you can use KPIs to actually feed your product feedback, and get feedback from it. But it's really hard to have specific KPIs as a system of control.
That's a really interesting answer. I've actually never thought of that before, and that's pretty interesting. I don't know if I agree with it entirely, but I also, for time, but that's interesting. I never really thought about that. I think my answer is much more Kind of similar to yours, Mark, but it's the, you should, don't go in saying, hey, this is what we're going to do, because as you said, like, if you say, hey, we need to improve efficiency, like, you're going to try to just do that one number by any means necessary. So you're kind of putting a band-aid on the problem. You're not actually going in and solving the root cause of it. I think my advice would be almost like be scientific with it. Be as objective as possible. Get as much information as you can, kind of get a level set, and then go, okay, let's try to increase efficiency here, or let's try to increase quality. And then just slowly do your best to try to make those small incremental changes. But again, be open about it, be scientific. And hey, that really what I'm saying is, if you try something and it doesn't work, that doesn't mean the project's a failure. You're still getting this data. You can still make decisions and change behaviors, but just do it in a way that is impactful in the long run, and not just for that short-term result. That, Mark, as you said, like, hey, just hitting a number just to hit it, not to actually help improve things. That's a really, really interesting point.
I actually agree with that from working in manufacturing for over 30 years. People are interesting. Let's just leave it at that. But all kinds of, they do modify, if they know they're being watched, they modify their behavior for what's being watched for. And so it's not always something that you can trust. So from the three of you, and you interact with a lot of different customers and all over the world, what kind of emerging trends or technologies do you foresee having a significant impact on industrial analytics in the future? What do you think?
Yeah, I have a feeling our answers are going to be similar here. But for us, the thing that we've been seeing, and I kind of alluded to it before, is data modeling and advanced contextualization at the edge. So, I had said at the top of the hour, basically, where, hey, there was this example of, hey, we want all this data, and then people going, that's too much, we can't handle all that, let's back it up, to now, hey, we actually can analyze these large data sets. But the problem is, all of those advanced analytics, cloud-based solutions, whatever they may be, surprise, they're not good at contextualizing that data. They can analyze it, but they don't necessarily know what that is. So what becomes interesting is, you have to have a way for these OT engineers to essentially say, this is what this data actually looks like. This is what these Modbus registers are. It's not just a bunch of, it's not 40,001, 40,002. It's, hey, this is temperature of our tank. This is the pressure in our valves, whatever it is. An IT analytics person isn't gonna know that, just like an OT person isn't gonna know the intricacies of analytics. But the OT person will know what these mean. So it's sort of a, how can we do that at the edge before it gets up to the cloud or wherever? It's how can we do that in a way that is contextual and fulfilling, I guess, before it gets set up. So we've been seeing that. There's a bunch of companies that are starting to do this. I would encourage everybody, go check out the HiBite webinar. They're phenomenal. They're actually extempore people. They're down the street from us. It's awesome. And I really think that industrial data ops, that contextualization, that is the next big emerging trend, and it's important.
Yeah. Just to complement, I think this concept of data modeling, it's this concept that I think Walker Reynolds coined, with the unified namespace. It's really one of the trendy technologies or architectural patterns that we see more and more on the industrial IoT. These, along with a broker that can feel this semantical hierarchy of the data and assets that are sending data in real time. So you have this single source of truth somewhere, and any service that you have on the factory or on your company can just subscribe and publish data there. So this is something, a trend that I see more and more, and it's simple to, well, not simple, but it's useful to have. On the software side, I think I see two different trends. One, I think it's mentioned as well on the Q&A here on Zoom. If you have questions, please add. But I think the popularity of the low-code, no-code tools just really reduce friction to a lot of people. Even if you are IT or OT and you don't have any programming skills, this type of tools I mentioned before, Node-RED, but there are a lot of others. available in the market, like Lozant and so on. That allows a lot of people to create these workflows and these business logics in a really simple way. Something else that I see, and I will point here Jay, because he's the one who shown me, I see more and more software trying to reduce friction and adding some capabilities that then you don't need to add on your application. So let me give you an example. So with Jay, we were doing this project with the Ming stack, whatever, on industrial IoT. And what he decided to do, instead of building an application about predictive maintenance, he just moved all of these business logics into the InfluxDB, which allows you to run this type of algorithm. So I see more and more this type of software that tries to reduce the friction to achieve specific tasks. And this is really interesting because that actually simplifies a lot the workflows.
Yeah, and I think to all your points, I think from coming at from a different point of view is now working at InfluxDB, I've had to delve into the other side of the market, which is not industrial IoT at all, which is monitoring and observability for IoT systems. And it's almost like industrial IoT's trailing just on the tail of where they're coming from. So, when we look at, say, a server monitoring, we started with server monitoring, looked at like CPU usage and etc. and all those different sensor points to see how your web application's performing. And now we're into the observability phase where people are now drilling down into what parts of their code are breaking, or what's causing a latency between different services. And I feel that's where industrial IoT is going, where you have that broader look of your entire system. You can work out where your weak links are, but also being able to drill into the finer parts of your machinery and look at that very granular data level to see what's going on. And I think that's really where that relationship from cloud to edge is really coming into play. I think for us at InfluxDB, we've really seen that. A lot of our customers are screaming for more edge to cloud and cloud to edge as well, both of those, that bridge being hardened. So that's really where we'll be focusing on, and hopefully in the future.
Yeah, I think another trend here that I'm seeing in Mark, I think this is much more your world than it is mine, but the container technology making its way to the factory floor in particular has been really interesting. And again, my rule of thumb is usually our industrial industry is like 10 years or so behind the general commercial space. Ethernet being on the plant floor in 2010 maybe. I'm like, what is this? Anyways, but I think container technology being applied in that industrial space is becoming really interesting, and I think sort of the holy grail for trying to solve that. So if you look at, I think the big trend here is just, hey, we now have the ability to interpret and analyze humongous sets of data, which also means that there is a large deployment of softwares out there, let's say Kepware, even just going out and trying to collect all of that data. That's really, really hard to manage, and that's really tough to deploy, especially, for a bunch of reasons. You can't just go press a button, go deploy a piece of software down the plant floor. There's a lot of reasons why you can't do that. Containers allow you to do that, but I don't think companies are necessarily there yet to be able to adopt that technology. I know, what are your guys' thoughts on that as the container experts here?
No, to be honest, we see at Balena, we see more and more companies on the industrial ecosystem and industrial space, that when they need to design a new product, they just say, okay, we need to use Linux, we need to use containers, and we need to have control of the software running on our new product. Because we don't want to repeat what we did in the past, and this is really like proving that a lot of companies are going towards that direction.
Mm-hmm.
So we are nearly out of time. Is there any one key takeaway that each of you would like to share with the audience? A hint that's gonna, the magic that everyone's looking for.
Yeah, I mean, I'll take a stab at it. I think in general that the big takeaway here is the importance of data. I think everybody, and I kept seeing it in the comments, which I love. It's one of my favorite phrases, is like, data is the new oil, and it absolutely is. But the key takeaway here is You can have all that data, but you absolutely need to have a plan of what to do with it, because it's useless if it's just sitting in a data lake somewhere. You have to have an actionable plan to do that. So, and again, how you get that data, I've got my own opinions on that, but really for me, the key takeaway is it's so important to have a plan of action to do with that data.
And I think for me on that point, Carl, as well, it's the transparency at each stage of the process as well, is being able to see your machine data and then store it and being able to transform that into business insight. All of that data is important to someone somewhere, and seeing how you've arrived at that decision where in some form of business insight, it's important to know what the underlying machine data looks like and how we shape that to receive those results. I think that's really important. And that comes from having an open technology where you provide the building blocks that lock these data pipelines together.
Yeah, and today I don't want to miss to talk one of my favorite topics as well, that it's the business model innovation into the IoT. So usually if you start taking steps towards the industrial IoT, maybe the business models that you used to use in the past are not going to work for this new generation of products. So yeah, you will need to innovate on that. So.
Yeah, I agree. You have to foster a culture of innovation, and that's really crucial. And we have one more minute if you want to add some more content to that.
I mean, I think that, open and agnostic, I think that's been a theme for us as well. And that's for Kepware, that was our whole bread and butter from the early 90s. It was an agnostic approach, and we still maintain that. Sure, we still have, we're a PTC company, but we still maintain that we don't care where the data goes. We will help you get it there. So, right. And again, that goes to the agnostic open. I think that's super important.
Yes, very good. Okay, so I want to thank everyone, our speakers, for, I've lost my screen. Please rate the session. But I'd like to thank our speakers for joining us today and providing these valuable insights. And I'd also like to thank our sponsor, so Inflex Data, because your sponsorship supports make sure that we have all this great content to share. And thank you for the attendees for listening and the great questions. I know there's a lot left to answer, and we'll follow up with those separately. So now it's time to move to the next session, the importance of having a good data strategy, which I believe is a perfect segue from our panel. So some of the questions that were asked, you might get the answer here on the return on investment and the strategy of good data. All right, thank you very much.